Alright, in this session we're going to talk about face milling. In most cases, whenever you write a milling process, we want to expose the top of the part, and face milling allows you to do that real fast. Usually you don't have to take off a whole lot of material. The smaller the part, usually the less material you have to take off to get 100% cleanup. Now it depends on what kind of material you're working with, and the larger the part, the more irregular that surface is. You may have to run an indicator over the top to see what your lowest point is. Okay, so anytime you set your work coordinate, you want to make sure that you set it to the Z0, which is usually anywhere from 20, 30, 40 thousandths below that raw material surface. Okay, so when we do the milling operation, we are exposing Z0. Okay, so for this operation, or for this example, I'm using a part that's 3 inches wide, 6 inches long, and in most shops you're going to find a 2-inch face mill. That's just kind of a standard size. Okay, so for this size part, we'll be able to make a pass from left to right, come over to the other side, and come back and expose that surface or remove that top surface in just 2 passes. So let's take a look at it from the top. Let's go ahead and play and see what's going on. So the first thing I want you to notice is the amount of overhang that we have. We want to make sure that we can do this part within 2 passes, but we want to make sure we have some overhang. Okay, so it comes across. We came all the way off the part before we come across. Then we have the same amount of overhang on the way back. Now, because the tool is spinning clockwise, let me go ahead and show you that again. Because that tool is spinning clockwise, it's actually pushing the burr back onto the part. Okay, and so you always want to make sure that you're moving that tool across that edge in a way that you're not creating a huge burr. If you were going the opposite direction, you would have huge burrs hanging off of that edge. Okay, so by doing it this way, you're avoiding that or minimizing that. All right, so notice that our X0, Y0 is set in the upper left hand corner. So let's take a look at the code that we would write to make sure we have overhang, that we come all the way across the parts, come across and have a complete cleanup. Alright, so when you get ready to write the code, I would suggest that you create yourself a sketch like this, and remember that we are programming the center of the tool. So if the tool is 2-inch round, we want to make sure we add at least 1/4 inch just to be safe, to clear the part on our entry. We come down to Z0, we come all the way across. We want to make sure that we have enough overhang. And then when we come across the other side, we want to make sure that we clear the part, so 1.25 inches is safe again. Then we move across to the other side. Now we have a 2-inch cutter, but we don't want to use the max 2 inches. So the max I would suggest on a 2-inch face mill between passes is 1.750 inches. And in this case it worked out that on the way back we have exactly 0.375 overhang again. Okay, so we start on the left, go to the right, come across and over. So let's put some XY coordinates to that. So our start position would be X minus 1 inch 250, Y minus 625. Then we go to a point at X 7 inches 250, Y minus 0.625. We come across, then we can either do a fast feed, even a rapid move, or just the same feed, just to not make any mistakes. And then this is our endpoint. So let's go ahead and plug these numbers into the GWizard editor. Alright, so I have written the code for this operation, and I'm going to go ahead and keep this program up because the next couple of videos I'm going to add to this program. We're going to do a drilling operation next. We're going to do some center drilling and tapping, and I'm going to add to this program right here. And then we're going to talk a little bit about format, messages, and instructions at the top of the program so that you know the tools that are going to be used inside that program, and so that the operator will know what tools to load and where to set the XY origin. So we have program number 1 with part number 1234556-1. Our XY origin is the far left corner. So far we're using tool number 20, which is a 2-inch face mill. Then we have our safety line, G0, putting the machine in rapid mode. G17 is the plane selection. On a 3-axis vertical mill, make sure that you always set the plane selection to G17, because that is important when you write clockwise and counterclockwise arcs. The G17 refers to an XY plane selection. Okay, G18 is an XZ, which is usually used on a lathe, and then G19 is YZ, used on multi-axis machines, but could possibly be used on a 3-axis mill. So make sure that you realize the G17 is there to set the plane selection for a 3-axis mill, so we can do clockwise and counterclockwise arcs. G40 cancels cuttercom, G49 cancels tool length offset, G80 cancels canned cycles, and you know what G90 means. It means we are in absolute mode. First operation we're going to do is a face mill. We're going to use tool 20 with an M6, making a tool change. Then we wrap it to X minus 1 inch 250, Y minus 625 in relation to G54. We turn on the spindle, 1350 RPM with a clockwise rotation M3. G43 goes to the tool data page, picks up the tool length offset for tool 20. We wrap it to Z1 inch, and on that same line we turn the coolant on. Now I highly suggest that when you wrap it down in Z that you stop 1 inch above the part. First of all, if you do your first piece program prove out, you want to make sure that you can stop the rapid move in time before it crashes into the part. Okay, I would suggest no less than 1 inch. Then once you have verified that 1 inch is truly 1 inch above your part, you can wrap it to the next Z level, Z.1, and then we go into feed mode to Z0 with a feed rate of 50 inches a minute. So remember, the G1 is modal, so we're going to feed to X 7 inches 250 with a feed rate of 30 inches a minute, come across in Y and go back to X minus 1 inch 250. Then we wrap it to Z1 inch. We turn off the spindle, we turn off the coolant, and here's that G91 mode that we talked about in previous lessons. That's the home up move in Z, and we're doing a home up move in Y. And then we change the machine back to G90, and M30 rewinds the program back to the beginning and stops and waits for a cycle start. Alright, so let's move on to the next video where we talk about center drilling.